Hello, welcome to week 14, our penultimate week in the ESTEP course. So this week we're going to be doing something slightly different. You now have a broad introduction to nearly all key topics in earth sciences, except for fossils. That's next week. What we're going to do this week is look at some more applied aspects of earth science or geology that are relevant to the upper Midwest and broadly the entire US. But let's dive in now. Okay, so as I mentioned, this is a broad range of natural resources related topics: hydraulic fracturing, also known as fracturing, silica sand mining, and whoops, I've pulled out pipelines because I decided we didn't have time, landfills, and then we're going to investigate the EPA in a separate video. Here we're in an area of North Dakota, I can't remember exactly where it is, where we've got some hydraulic fracturing taking place on this pad, if you like. And what I want you to think about now is, okay, we're looking at this natural landscape, and you know about surface water and groundwater. What questions might you have about the impact of fracking on the natural landscape as you can see it, and what is beneath what you can see? So let's dive in. First of all, before we dive into hydraulic fracturing or fracking, I want to look at the simple story behind the generation or formation of petroleum, which includes both oil and gas. So here on the left, hundreds of millions of years ago, we have microscopic organisms in the ocean. They die, they fall to the sea floor. We could substitute an area on land where we have organic matter, in other words, mostly plant matter, collecting and being buried. And over time, that dead plant and animal matter will be buried by other layers of sediment, whether it's on the sea floor or whether it's in a swampy type area that gets buried by other sediments. And over time, this dead plant and animal matter gets impacted by increased pressure and temperature. And over time, that increase in temperature and pressure will turn it into oil and natural gas. Now, there are two terms that get used for oil and natural gas reserves. We call them conventional reserves and unconventional reserves. And what we're going to be investigating today are unconventional reserves. Let's take a look at what that means. So, I want you to pay attention to the diagram first. What you're looking at is a sequence of sedimentary layers that has been folded somewhat. Now, in conventional reserves, what happens is that the oil and gas that is formed in the deeply buried and heated up rock will move through that rock and get preserved in areas where it is trapped. And the gas is less dense than the oil, so the gas always moves up to the top, and down below that will be some oil. So we're using some of the knowledge that you have from groundwater here. We have conventional gas and oil here, and conventional gas up here. Now, what we're interested in is the oil and gas-rich shale. So think back to what you know about shale. Shale is very fine-grained and it is impermeable and it isn't porous. It doesn't have those open spaces. But because of all the organic matter in that fine-grained sediment, it holds a lot of oil and gas in it. So the big challenge is how does that oil and gas get released? So looking back at the text over on the left, as I mentioned, many of the same issues associated with groundwater. It's stored in the rock, but can it move through the rock into an area where it can be accessed? And in the case of the oil and gas rich shale, the answer is no, it can't be easily released from the rock. And this is where the discovery of the process or development of the process of hydraulic fracturing is important, because that is how oil and gas gets extracted from shale. So that's what we're going to investigate. Before we move on, what I want you to notice is that in the conventional oil field, we have a drill that just goes straight down. Look at what happens in an unconventional oil or gas well. We have that drill going straight down, but then it can move and it can extend laterally into that oil and gas rich shale. So let's move on. Before we dive into exactly how the hydraulic fracturing works, I just want to introduce you to a few bits of terminology. This is indeed a quite dated map, but it gives you the big picture, and this picture hasn't changed. So we use the word clay for an area where oil and gas fields exist. And it doesn't mean that the material or the petroleum is being extracted. It's just, it is in existence. And the pink refers to current plays. And what was current in 2011 is still current today. So the big ones, the one that is effectively relevant to us because it ends up employing a lot of people from Minnesota that go here, is the Bakken. And the sedimentary basin that it is in is the Williston Basin, but it's called the Bakken oil field. And over towards the East Coast, once one gets into Ohio and Pennsylvania, it's the Marcellus, and that's because the unit here is the Marcellus shale. In North Dakota, it's the Bakken shale. So you'll notice here there's a bunch of other shale plays. Over on the left here are two videos that are in the list of video links, or you could just come back to the slides. You'll want to watch these two videos. I do want to note some of the videos that we're asking you to watch are sponsored or supported by industry. So they obviously have a industry-based perspective. So just to zoom in a little bit more, here we have the Bakken Formation in North Dakota. This dashed line shows the extent of the Williston Basin. So that's a depression on the Earth's surface that formed a sedimentary basin. in which the Bakken Formation was deposited. If we go to the Marcellus Shale, you can see its broad extent from southern New York, Pennsylvania, West Virginia, and into Ohio. And we've got a link I suggest you watch here. So, a summary of hydraulic fracturing. Let's just look at the text here first. So, as I mentioned, fracking is the term used for what is technically hydraulic fracturing. And what that means is cracks or fractures in the rock layers, in the shale that contains the oil and gas are introduced. And then as a result of, so they crack the rocks and then they introduce pressurized fluid and particles that keep the fractures open. And then because those fractures get kept open by the grains that are propping them open, those grains also get called proppant, the oil and gas will start to move out of the shale. So here we have our drill, and the simple story is we have these cracks or fractures that get made, that we also call them fissures, and then as a result of injection of drilling fluids that contain these grains of sand that prop the fissures, fractures or cracks open, then we start getting natural gas flowing into this well where it can be extracted. So I don't want to go and show a video during the lecture, but there are 3 really good videos here. And yes, some of them are industry sponsored, but they explain really well how it all works. So we mentioned that fracking requires this fracking sand, which also gets called proppant. So here we have some really good fracking sand. What are the properties of a really good fracking sand? Well, it needs to be a mineral that doesn't crack or fracture easily. So a mineral that doesn't have cleavage. So we end up going with quartz. Now, we also want to make sure that it is texturally mature, all about the same size, because we want to be sure that we can hold fractures, cracks, fissures open to a certain degree. And we also want it to be the same shape. So quartz is the fracking sand of choice. Here, there are a series of mostly industry provided links on fracking sand. It's worth taking a look at them. Now, this does go back a ways to 2011, but I don't think the percentage has changed that much. The percentage of globally available natural fracking sand, 59% of it was produced in the Midwest. So where does it come from? Okay, so it comes from one particular sedimentary unit, the Jordan sandstone. So here we're looking at the sedimentary sequence that characterizes Minnesota and extends into Wisconsin, and then in the subsurface it extends into Iowa. But in both Minnesota and Wisconsin, the Jordan sandstone is often at or close to the surface. So let's just take a look. Here we are in a quarry in Burnsville, and what we're looking at up at the top here is some of the Oneota dolomite, but we're effectively standing on a surface in Jordan sandstone. Over on the left here, we're looking at a silica sand mining operation that is in rocks near the surface. Well, where are these rocks exposed? So this is a map produced by the Minnesota Geological Survey. And it doesn't actually, oh dear, it doesn't actually have the key on it. But in red, the silica sand mining resources, in other words, Jordan sandstone, where it's exposed at the surface. In pink are the areas where it's close to the surface, but not right at the surface. So southeastern Minnesota is the area, excuse me, the area in Minnesota where silica sand mining is important, is an issue. There are also locations along the Minnesota River Valley where the Jordan sandstone is exposed at the surface or is very close to the surface. Okay, so that's a brief trip through hydraulic fracturing and silica sand mining. Other topics that you could consider thinking about are what are the impacts of hydraulic fracturing and or silica sand mining on groundwater, surface water, air quality, and things like noise and other types of pollution. So we're going to change topics now, and we're going to start thinking about where our trash goes. So there are actually a bunch of different types of landfill, and a lot of this gets into legalities and fine print. There are specific guidelines and rules for construction of landfills. And then there are the hazards associated with landfills. And essentially those hazards are when the containment method that's used fails and contaminants end up getting into the groundwater. So down here on the left is a list of the different types of landfills, municipal or solid waste landfills. This is where most of the waste that we're familiar with goes. Then there's hazardous waste landfills. There's demolition landfills. This is where demolition material, like concrete and wood, will go. And then there's also some industrial landfills. So over on the right here is a diagram that captures the freeway landfill and dump. It's in Burnsville next to 35W. And it captures the key elements of a landfill. And this, for our purposes, we're going to start by just thinking about, okay, we're worried about where the water is going to go. So if we have a dump, and that's the word that used to be used for them, we'll get to that, we need to think about what is stopping material from getting into the groundwater and how are we managing that process. So Now, it used to be that the term dump was just used for anywhere that material, the waste material, got put. In 1967, in Minnesota, the landfill program was established by the MPCA, that's the Minnesota Pollution Control Agency. And that's because they recognized that these dumps were producing, in many cases, pollutants, and there needed to be a system of management. So the MPCA manages what we call open landfills and closed landfills. So that's effectively ones that are operating and ones that have ceased to operate. And public in general seems to still use the term dump, even though it is an antiquated word. Technically, the MPCA uses the term dump for a landfill that never held a valid permit from the agency. So in other words, all those landfills that existed prior to 1967 that never got grandfathered in to their management system. So let's take a look at some landfills or dumps in Minnesota. So in Minnesota, there's a specific program that manages or called the closed landfill program that maintains municipal waste landfills. And they are responsible for ensuring that the long-term care of these landfills are being addressed. And so what are the concerns around landfills? First of all, there's leachate. This is the word used for the mostly waterborne potential contaminants that move through a landfill, that have collected contaminants. Sometimes there's chemical reactions within material in a landfill, but regardless, it's that you can think of it as a pollutant soup that develops, and dumps need to manage that. Then there are gases given off by the landfill. How do they manage that? And broadly, the management of these two get rolled into dealing with potential contamination of groundwater or into the air. So a key part of managing this is monitoring. So in many locations, there are monitoring wells. Think back to our investigation of groundwater. We looked at ordinary water wells. Well, there are monitoring wells that are set up on a local basis to monitor what is happening to the groundwater, to make sure that we don't have contamination. And so, so far, we hope that everything has been managed appropriately. But if there is a contamination issue, the MPCA is also responsible for directing the management of the risk for the public. In other words, mitigating the risk. And that involves a lot of communication with the local government. In some of the links that you have, you can get to a myriad of resources on dumps. So what we're looking at here is a map that shows what are called the closed landfill program locations. So these are landfills that ended up being closed. In other words, shut down as a result of that 1967 location. And all of these landfills will be continued to be monitored. And there's some that for some reason aren't in the program. So the next thing we need to think about is how exactly are municipal solid waste landfills. So again, these are the landfills that our trash, garbage, whatever you want to call it, gets taken to. And there is a lot of fine print that can be quite overwhelming. So broadly, what we're going to be talking about gets called sanitary landfills. They're also municipal solid waste landfills, non-hazardous landfills. They also get called subtitle D landfills. That has to do with the fine print. And there's two really interesting links to go to here that can direct you towards information on landfills in Minnesota. But let's take a look at this diagram overall. So we've got in this diagram, we've got the brown material in here, which we're just going to treat as surface sediment, okay? So we have a big pit that gets excavated in that surface sediment. And there are a bunch of different liners that get put in. These include clays, but there are also some synthetic layers with sand in between. Remember, sand is porous. So within that sand, there are going to be some pipes that go in that collect the leachate. In the center is compacted solid waste. So that is everything that gets dumped. What we're looking at is a sanitary landfill that has effectively been closed down, but it still gets monitored. So remember those pipes I was talking about? They all feed to what we call leachate storage tanks. And those leachate storage tanks send the leachate to a leachate treatment system. And that treatment system basically extracts pollutants and then and exactly how this works varies, but it puts the clean water back into the natural setting. There are also gas, and it's particularly methane that gets generated. It gets extracted from the compacted solid waste, and there's a methane storage and area. So what's also really important is if you look over to the left here, you can see a couple of monitoring wells here and over here on the right. So these wells are monitoring the groundwater to make sure that there isn't any contamination. So let's just jump into some more specific Minnesota related issues. Hazardous waste in Minnesota. So this is where we start interacting with the Environmental Protection Agency and some of their rules and regulations, which include the RCRA, which is the Resource Conservation and Recovery Act. This gets pronounced RCRA. And then there are some specific Minnesota hazardous waste rules. And you can go and locate hazardous waste sites if you use these two links here. I put this image on the right up here so that you just get an appreciation of the complexity around the management of hazardous waste. So what ends up being different about a hazardous waste landfill construction? There's a lot of features that are similar. So when you look here, you can see there are gas vents, there are groundwater monitoring wells, but essentially the containment system and the number of liners and the number of leachate collection systems is vastly increased. There's information in the link on the left. There also exist demolition landfills. Technically, these seem to be the C and D landfills. As you can probably tell, the fine print is kind of overwhelming here. Now, these demolition landfills are actually managed separately to the sanitary landfills, still by the MPCA. And they're actually currently working on rules and regulations, and I haven't kept up with any recent changes. And, you know, one of the questions here is, do they impact groundwater? Now, typically, they are not lined. So if you think about if you've had any construction done and you live in an urban area, they are very strict about what you put into your dumpster. This is the reason for that. The landfills that demolition materials go to are not lined. So what are people particularly concerned about with a demolition landfill? This gets to arsenic, boron, and manganese. And if you think about your roofing tiles, some of which we can see here, they typically contain quite a bit of arsenic. So there's a lot more information on them here in that link. Now we get to a biggie, nuclear hazardous waste. So in Minnesota, we have 2 nuclear power generating facilities. We have Prairie Island and Monticello. And the Prairie Island has a long and messy and very complex history. In the 1980s, material was stored in steel-lined concrete vaults that were actually surrounded by water. Then, once we got to 1982, it turned out that the Nuclear Waste Policy Act that was supposed to be moving into effect in 1998, that fell through. And in 1991, the plant needed extra storage space. The material is, or the used material is still stored on site as far as I understand, but they need extra storage space. As a consequence of some of these challenges, the construction of any more nuclear plants in Minnesota is prohibited. At the moment, the only, how do I say this? As I understand it, the only approved US-wide nuclear waste storage is in areas to the west of Minnesota. And so nuclear waste would have to be transported by road if it wasn't stored on site. And the hazard of transporting it via road is significant compared to storing it on site. Now, that's something one can debate. So, what this is showing is the nuclear waste storage sites in the US. So the green triangles, which are few and far between, are the Department of Energy owned or managed nuclear waste storage sites. So Washington State, Idaho, then we come down here to Kansas, and then we go into Western Pennsylvania. And that is it. Otherwise, material ends up being stored on site. So with that, we have finished a quick tour through some applied topics. In a separate video, part 2, we're going to look at the history of the Environmental Protection Agency. See you then.